All right, first year Master of Science students in SH 503. Welcome now to this last part of this conformation analysis. And we're going to be looking at these rules which were formulated by a scientist called Jack Baldwin. And they're just called Baldwin Rules. You may think they were probably formulated in the 1900s or whatever. Yes, in 1900s, but quite recently, about close to 1980. It was just the other day, about close to 40 years ago. Yeah, not a long time. So these are rules which describe the there's the thermodynamic in which you're talking about the most stable, but in this case you're talking about how quickly, you're talking about kinetic feasibility of ring closure. Kinetic means how fast, as opposed to thermodynamic, you're talking about uh, the formation of the most stable. So these rules do not apply to the second row elements. Like in this case, you're talking about carbon has got uh, 4 bonds. So in this case, you'll be talking about silicon, uh, or even sulfur and the rest, or even the ones which have got access to the d orbitals. Then these rules do not apply. So we will only be talking about like the first row up to fluorine. Yeah. Yeah. So in this case, the reactions are going to be classified into either a favored, RC means ring closure. You're going to see the word RC. So there's the favored ring closure. In this case, we are saying the length of the chain and also the nature of the linking group or the atoms, their nature. It means that because of these two things, then the terminal atoms, you're talking about there, there is an atom on one side and an atom on another side. So in this case, it means that in one case, you're going to have a nucleophile means there is uh, I think I should have done this one earlier. The nucleophile is is a group or an atom which has got electrons which can be donated. It is better if it is negatively charged, but it can be neutral, yeah. But it's got electrons, which or a shell, no, or an energy level which can donate electrons, yeah. As opposed to an electrophile has got a shell which can receive electrons. It would be best if it will be positively charged, but it can also be neutral. Like in this case, you'll be talking about uh, Lewis acids like boron or aluminium. Yeah, it's got a vacant orbital which can receive electrons, but it is not positively charged. In that case, you can talk about it being or like something like a Lewis acceptor. So in this case, uh, uh, you're talking about the reaction between a nucleophile attacking an electrophile within the same chain. So in this case, you say uh, uh, the chain needs to be sufficient. Yeah, because it can be too short that you've got a nucleophile and excuse me, you've got a favorable nucleophile and an electrophile, but because the chain may be too small, you may not get a favorable ring closure. So in this case, you're saying because you've got the length and the nature of the linking groups are okay, then the terminal atoms are able to achieve the required trajectory to form a ring. Now, this is what I'm going to be describing shortly after I've gone through these terminologies. For example, we'll be talking about X on the end. I'm going to talk about those ones, but later we'll be looking at what you mean by the required trajectory. Like, but just something which you may need to know is that if you're talking about something like tetrahydrocarbon, you'll be talking about uh, the nucleophile and the electrophile which is leaving, they need to form an angle of 180 degrees. But that's what I'm going to come to later. So Disfavored ring closure, it means that there is a severe bond angle and distance distortion such that the desired ring closure will be difficult to achieve. Please know that you're talking about a disfavored. You're not talking about a forbidden. There's a difference between allowed and forbidden. This terminology will come to know in one of the topics which I'm going to be calling pericycle, where we'll be talking about allowed and forbidden. But in this case, you're talking about favored. Favored. It is favored or disfavored. Yeah, because later you're going to see, or maybe there are some publications which I think I may show you, in which there are some exceptions to the Baldwin rules. Yeah, all right. So there are two terminologies which you're going to know for the first one, and that is the two words exo. It means that the atom or the group receiving electrons is outside the forming ring. Like in this case, there is a tetrahydrocarbon here, in which the nucleophile is attacking, and then there's I don't know whether I should have put a group or I should have put, let me change that out from the group to L. L means a living group. I think that would be much better. So there's a group which is receiving electrons, and then it is departing. So that group, in this case, let me show here in red. The one which I'm showing is in red is the ring which is forming. Can you see that? So the group which is leaving or which is receiving electron is outside that ring which is forming. Now in this case, this is a tetrahydrocarbon, this is a trigonal carbon, whereby the group which is receiving electrons, like in this case, it can be oxygen, nitrogen, for example, it is outside the ring that is forming. And also, you can also have like a what? Like a triple bond, whereby the group which is receiving electrons is also outside the ring which is forming. So in that case, that is called exo. Can you see that? So it means that the endo, you're going to have the opposite, yeah? So that the nucleophile, in this case, uh, so the ring which is in the ring which is going to be forming, in that state of the ring forming, there's a group which is receiving electrons, and then can you see the group which is receiving electrons, or where the electrons will be forming? It is part of the ring. In this case, this is what the electrons will be forming, and everything is part of the ring. Everything is part of the ring. So in this case, this is taken as endo. Yeah. So later you're going to see uh, uh, the required trajectory that for some rings, that this one for the nucleophile attacking here and this thing coming up here may not be possible for some ring systems. Also, for these ring systems, some things may not be possible. So that you are going to come to see the ones which are going to be favored. If you're talking about a 3-membered ring, 4-membered ring, 5-membered ring, probably a 6-membered ring, and the rest. Yeah. So for this one, the terminologies that you need to know is the exo and the endo. Yeah. Whereby uh, the forming ring, in this case, the nucleophile and the one receiving electrons there, they're within the same ring system, which is where the electrons are actually ending up. You're talking about a system in which it's in a continuous ring, as opposed to in this case here, the system which is receiving electrons is outside. Yeah. What I'm saying is that that one is outside, this is outside, this is outside. Everything else is, this is inside the ring, this is inside, this is inside. Can you see the difference? Good. So I'm just going to press pause, and then we look at the different ring systems, and then we'll proceed from there. All right. So I'll just press pause, and then we'll continue shortly. All right. Let us proceed on. Uh-huh. What can you see here? Uh, I've just drawn a 5-membered ring in this case here. So X is the nucleophile, showing in this case got electrons. Here is a carbon, this is a tetrahydrocarbon. this what do you call a trigonal? It means that okay, you can say this is an sp3 hybridized carbon. This is an sp2 hybridized carbon, and this is an sp hybridized carbon. Yeah, sp for a triple bond, sp2 for a double bond, and then sp3 for a tetrahedrocarbon. So in this case, the group which is leaving is on the outside, or the one receiving electrons is on the outside of the ring which is forming. So this is the terminology that you're going to say. You're looking at the forming ring has, in this case, has got 1, 2, 3, 4, 5. So you're going to be forming a 5-membered ring. So you're going to put 5 here. If you're forming a 3-membered ring, then you're going to put a 3. The group which is forming, which is receiving electrons is actually on the outside, so I'm going to use the word exo. And then it's a tetrahedrocarbon, so you're going to use the word tet. So it's 5 exotet. So if the group would have been the one on the inside like this one, this would have been a 5-membered ring. This would have been a 5 endo, and then tet. Have you seen the difference? Now, this is the nucleophile, and this is the tetrahedrocarbon. This is the one receiving electrons, and therefore the ring which is formed, the one receiving electrons is on the outside. So these are 5 exo, and then there is trig, yeah? So if the one receiving electrons, like in this case, I would have been forming a 5-membered ring, I would have put the word 5 endo trig. Okay, now the one receiving electrons is outside the ring which is forming, and I'm forming a 1, 2, 3. Oh, so this is a, sorry, this is a 4-membered ring. 1, 2, 3, 4. So this would have been 4 exo D. So like if I would have been forming a 4-membered ring, then so that would have been 1, 2. Okay, what I'm saying is this. If I would have been having something like that, I would have had 1, 2, 3, 4. I would have a 1, 2, 3, 4. So it would have been a 4 endo dick. If the electrons would have been ending up like that. Are we together? So those are the various descriptions for the for the uh, for the ring closure. So now I think what you'll do is that uh, I'm not going to stop this video, and then we look at we'll first of all start with the tetrahedral systems, and then show the various ring systems from 3, 4, 5, 6, 7, probably up to 6, 3 up to, I think we'll go up to 7, and then we see the ones which are allowed and the ones which are no, the ones which are, I'm using the word allowed, the ones which are favored and the ones which are disfavored. Yeah. So in a short while we'll be looking at, first of all, starting with the tetrahedral systems, and then we'll go to the trigonal, which means there is a double bond, and then the digonal system, in which there is a triple bond, or the bond angle is 180 degrees. Yeah. So we'll take a break, and then I'll be able to go to the next, now to the more elaborate in looking at tetrahedral systems. Okay? I hope you've enjoyed this session. Okay?